Hello children, hope you all are fit and fine at your home and also are studying through these online video classes and the notes. So children, today we will continue our chapter, that is chapter 4, materials, metals and non-metals. Already we have started this chapter in the previous week and studied about the physical properties of metals. Okay, so now this time in this video we will now going to study about physical properties of non-metals. So now let's come to this topic, physical properties of non-metals. The first physical properties is physical state. So children, as you already have studied in according to metals, in metals, the metals are existing in only maximum metals are existing in solid form and only one metal, that is the mercury, exists in liquid form. But in the context of non-metals, non-metals exist in all three forms: solid, liquid and gases. Okay, for example, sulfur and phosphorus are solid non-metals. Bromine is the only liquid non-metals. Please remember, mercury is the only liquid metals and bromine is the only liquid non-metal. Okay, and oxygen, hydrogen, nitrogen, these all are also non-metals, exist in gaseous form in normal room temperature. Okay, so non-metal exist in all three forms: solid, liquid and gases. Now comes to the next physical property, that is the color. So color in metal, what we have studied? Yes, I know that you are also telling. Color of the maximum metals are grey or grayish silver, and some exception are there, two exceptions, like gold having golden yellow and copper having reddish brown. But in non-metal, in the context of non-metal, non-metals are of different colors, okay, or also some are colorless. For example, like phosphorus exists in white or red color, sulfur exists in yellow color, chlorine exists in greenish yellow color, and also bromine exists in reddish brown color, and nitrogen, hydrogen, oxygen, these all are exist as colorless. Okay, so we conclude that non-metals have different types of color. There is no any fixed color like that of metals. Metals maximum are having grayish silver color, but non-metals are existing different color as well as in colorless also. Okay, now comes to the third property, appearance. What we have studied in metals, we can recapitulate also through these physical points. We can recapitulate about the properties of metals as well as non-metals. We will compare also. Okay, so appearance, what you have studied in metals, you have studied that metals are having luster on their surface, means they are shiny on their surface, but non-metals are dull in appearance. They don't have shine on their surface, they don't shine through their surface. But there is one exception. The exception is graphite and iodine. If you see your nib of the pencil, then you must have noticed that that nib of the pencil is shining too much, having luster. Okay, so graphite and iodine both are non-metals but have luster on their surface. Okay, that is the exception. So now, but generally the non-metals are dull in appearance. Now comes to malleability and ductility. What we have studied in metals, metals are malleable, metals are ductile. That means they can be hammered into thin and thinner sheet and also can be drawn into thin wires. But on the other hand, non-metals are non-malleable and non-ductile. That means they cannot be hammered into thin sheet as well as they also cannot be hammered into thin wires. Rather, they are brittle. Brittle means if you hammer them, they will divide into pieces. Okay, means they will not drawn into thin sheet or thin wires. Instead, they broken down into pieces. That's why they are brittle in appearance, brittle in texture, but non-malleable and non-ductile. Which one? Yes, non-metals. Now comes to conductivity. Conductivity means, as I have already told in the context of metals, that Metals are very good conductor of electricity, not only electricity but also heat. Metals are very good conductor of heat as well as electricity. But non-metals are generally very poor or non-conductor of electricity. Okay, non-metals are very poor or non-conductor of electricity, but there is an exception, and that exception is again graphite. Yes, children. Graphite is very good conductor of electricity. That's why it is also used as electrode in the cells. In the cell, you can see that graphite is used as electrode inside them. Okay, because it is a very good conductor of electricity. It allows the electricity to pass through it, and also a very good conductor of heat. Not only graphite but diamond also. Diamond is also a very good conductor of heat and electricity. Now comes to this one. But other nonmetals are very poor conductor or non-conductor. Now comes to density. Generally, the nonmetals are having low density. They are soft. But what we have studied in metals, metals are having very high density. They are strong. Okay, they are very hard. Very hard. But nonmetals, they are having very low density as well as they are also very soft. Exception is also there. Yes, children. The world hardest substance ever known, that is the diamond. Diamond is a non-metal which is the hardest substance known in the world. Okay, so here also we can, exception is diamond. Okay, because it is very hard and having high density. But generally the non-metals are having low density. Now comes to the next property, that is the tensile strength. Tensile strength, as I have already told in context of metals, that metals are having high tensile strength. That means they can bear very heavy load. They are strong. They can bear load. That's why in building, in bridges, for making the building bridges, you can see that iron is used because it is having high tensile strength. Not only iron, but different metals are also having high tensile strength. But non-metals are not having high tensile strength. They are broken into pieces. If you give the stress to them, they are not very strong. Okay, so now comes to melting and boiling point. So again, in metals we have studied that metals are generally having high melting and boiling point, but non-metals are having low melting and boiling point. One exception is there. Yes, of course, that is graphite. Exception is graphite. Graphite is having high melting and boiling point. So now comes to the next property of the non-metal, that is the sonority. Sonority, that means the ability of a metal or non-metal or any element to produce a ringing sound. Okay, in whenever we are studying about the metals, on that time we have studied that metals are sonorous. Means whenever we strike on this surface, it will produce a ringing sound. That's why metal strings are used in guitar, sitar, in temple bells, etc. But non-metals are non-sonorous. That means they are not producing any ringing sound if you strike on their surface. So this is all about the physical properties of non-metals. Now let's start some of the chemical properties of metals. Yes, children, so let's start the chemical properties of metals. Okay, so in this, first of all, we will study about the the reaction of metals with oxygen. So here we will see that metals, whenever react with oxygen, they form metallic oxide. Whenever any metals, all the metals whenever react with oxygen have the same type of reaction. They always form metal oxide whenever they react with oxygen. But along with these reactions, now we are going to study about different types of reactions of metals and non-metals. But along with this reaction, we will also study how to balance the equation, how to balance both the side of the equation. Okay, so that's why I have not balanced the equation right now. I will write the product first. After that, we will learn how to balance. So now, first of all, you have seen that whenever sodium, Na is the chemical formula for sodium. Okay, so this is actually sodium, and O2 is the chemical Okay, that's why they are kept in kerosene in order to cut the supply of oxygen, because whenever they're taken out from the kerosene, what happens? They react with oxygen vigorously in a normal room temperature and catch fire. Okay, so that's why the Na, whenever Na react with oxygen at normal room temperature, it forms sodium oxide, Na2O. It is sodium oxide. Okay, Na2O. Now here, first of all, we will write all the product first. After that, we will learn the balancing reaction, balancing of the reaction. Now, whenever Mg means magnesium, and this one is oxygen. A magnesium react with oxygen, it will form magnesium oxide, MgO. Okay, so magnesium oxide. This one is Zn, means zinc. Zinc react with oxygen, it gives zinc oxide, ZnO. Zinc oxide. Whenever Fe means iron react with oxygen, it gives ferric oxide, that is Fe2O3. Ferric oxide. Whenever copper, this Cu is the copper, react with oxygen, it gives copper oxide, CuO. Copper oxide. Okay, so these all are the products of these reactions. So now let's start with the balancing of equation. So what happened? Actually, first of all, in balancing the equation, we will first see left hand side and the right hand side. Okay, so first we will see in the left hand side Na, means sodium. How many atoms of sodium is here? If nothing is there, that means 1. 1 atom of sodium is here. It is 1 only. Okay, so it is 1 here. And now here you can see how many atoms of sodium? Here you can see 2. Now comes to oxygen. So sodium is not balanced, because in left hand side it is 1 and the right hand side is 2. So it is not balanced. Now comes to oxygen, it is how many atoms? You can see now. Yes, 2 of course, and here only 1. So oxygen is also not balanced. So what we will do first? So children, in this area you have to first put try the reactions, practice the reaction with pencil first. After that you put the pen. Okay, so let's start with we will put here in the product side 2. No, sorry. Here it is 2 already. So here we will put 2. So 2 Na, and again here also then oxygen will be here only 1. So what we will do? So here also we will put 2. If we will put 2, then 2 oxygen, but 2 2 ja 4 Na. Okay, so again the sodium will be unbalanced. So now we will put here 4. So if we put 4 here, then 4 Na, that means 2 2 ja 4 Na, and here also 2 oxygen and 2 oxygen. This 2 is for both, for Na also, for O also, for sodium also, for oxygen also. Okay, so here now the reaction is balanced. We will see left hand side and right hand side both. Now comes to the next reaction. Next reaction you will see that Mg, how many atoms? You can see that there is no atom, so it is only 1. And here also it is 1. So magnesium is balanced between left hand side and right hand side. But here in oxygen there is 2 atoms and here only 1. So what we will do to make it 2, we will put here 2. Okay, 2. So 2 oxygen, but along with oxygen Mg also becomes 2. Magnesium also becomes 2. Okay, this 2 is both for magnesium and oxygen. So what we will do? Again we will put 2 here. Okay, so 2 Mg, 2 oxygen, 2 oxygen. Now the reaction is balanced. Again for Zn, in the third equation, we will do the same thing. Again Zn 1, here also 1, it is balanced. Oxygen is 2 and oxygen is here 1. So oxygen is not balanced. So here it is less. So wherever there is less number of atom, we will put the initials there first. So we will put here 2 because 2 oxygen we need. So 2 oxygen, but along with oxygen Zn also becomes 2. Along with this 2 is for both Zn and oxygen. So what we will do? Yes, we will put the 2 here also. So 2Zn, 2Zn, 2O, 2O. Now the reaction is balanced. Now comes to this one. Fe 1, here 2. So Fe is not balanced. Here oxygen 2, oxygen 3. It is also not balanced. So what we will do first? So here 2, to make it 2, we will put here 2 first of all. Okay. And here 2 and 3. It is not possible to put 1 because 1, 2 are 2 only. Okay. So what to make? 2, here we will put 3. 3 2 are 6 and also here also we will put 2. 2 3 are 6 oxygen. In order to balance the oxygen, we will put here 2. 2 3 are 6 and 3 2 are 6. But along with oxygen, Fe also becomes 2 2 are 4. So here we will rub the 2 and put here 4. 2 2 are 4. 4 Fe. 2 2 are 4 Fe. 3 2 are 6 oxygen. 2 3 are 6 oxygen. Now the reaction is balanced. Now here also copper. Copper again 1 1 balanced. Oxygen 2 1 not balanced. So what we will do? Where the initial is less, here oxygen the number of atom is less, 1 only. So we will put 2 here. Okay. So along with, now the oxygen becomes 2. But along with oxygen, copper also becomes 2. So what we will do? Here also we will put 2. So 2Cu, 2 copper, 2 copper, 2 oxygen, 2 oxygen. Now the equation is balanced. I think so you have understand this balancing of equation. If you have any problem, any doubt, please children contact me in my personal WhatsApp number. Okay, so this is enough for today. We will study the next chemical reaction of metals in our next class. Thank you and have a nice day.